Hello friends and welcome to TMath. We're going to continue with our class on unit step functions. In the previous class, we showed how you can find the Laplace transform of such unit step functions, and we transformed it to functions of this nature. But for today, we're going to do the Laplace inverse of these functions to get back our piecewise functions. And to do that, we have a theorem which we're going to apply and solve a lot of examples. The theorem states that if tau is greater than 0 and the Laplace transform of g of t exists for s greater than s naught, then this function exists for s greater than s naught. This given condition, we know that gt, Laplace transform of gt is g of x. So this simply implies that exponential negative s tau Laplace transform of this is going to be the same as exponential negative s tau g of x, and we know this is Laplace transform of u t minus tau g t minus tau. Okay, and if we start to take the Laplace inverse of all the terms here, Laplace inverse, Laplace inverse, Laplace inverse, we can just pick these two. The Laplace inverse of exponential negative s tau g of x, which we know is this, as inverse dot Laplace will cancel out. We have t minus tau g t minus tau. Alright, and we're going to apply this by solving an example immediately. For this example, to solve this, first of all, before we apply the theorem, we want this to be in this form: exponential negative s tau g of x. Okay, and with this, so this simply implies that our tau here, by comparing these two terms, is just 4, and our g of x is 1 over s squared. So if our g of x is 1 over s squared, then our gt, which is the inverse of this, our g of x, this will simply give us t. Okay, and then now we found our gt, then our gt minus tau will be t minus 4. Apply this theorem. Okay, so we have this, and we want to get to this point. Okay, so everything we need is here, so we can easily do that. The Laplace inverse of e negative 4s 1 over x squared, this is simply going to give us u, remember we'll say it here, this will give us this. So we have u t, our tau is 4 minus 4, into gt minus tau. We already found our gt minus tau, t minus 4. And with that, we found the Laplace inverse of this. We're going to do more examples for more clarity. So for this second problem, we have to find a Laplace inverse of our h of x. And we can denote this by Laplace transform of h of t is capital H of x. So that implies that Laplace inverse of our h of x will simply be h of t, the function of t. And then to do this, if you look at this clearly, Laplace inverse of our h of x, this is the Laplace inverse of 1 over s squared plus exponential negative 2x 2 over a squared. Okay, and we can denote this to be our g naught of x, and this to be our g1 of x. And by doing so, our g naught of x is simply 1 over x squared, and our g1 of x is simply 2 over x squared. And if that be the case, then our g naught of t, which is the inverse of this, will give us t, and then our g1 of t, which is the inverse of the g1 of x, will give us 2t. Okay, and here our g1t minus tau This will give us 2t minus tau. And what is the tau for this expression here? The tau here is 2. Okay, that means our g1 t minus tau, this is going to give us 2 into t minus 2, which is 2t minus 4. Okay, so now let's apply the theorem that we've already learned. So that means that our h of t, which is the Laplace inverse of h of t, will just give us the Laplace inverse of our g naught of x plus Laplace inverse of exponential negative 2x, our g1 of x. And this we know already to be g naught, and this we've already established e plus, this is the shift, so this will be u t minus 2, and here will be gt minus tau. So, and our gt minus tau here is 2t minus 4, and this is the inverse of that function. So to put this back in the piecewise form, this should be of this in this nature. So this here will be our h naught of t and our h1 of t. But how do we find this? Clearly, you know that this is your h naught, and what you have here is your h1 minus h naught, all of t. Okay, so clearly our h naught is just t. Then to find our h1 of t, we have to use this, and our h1 of t will simply be h1 minus h naught plus h naught, and h1 minus h naught is 2t minus 4, then plus h naught is t, and this will give us 3t minus 4. So what we'll have here, we'll replace this with 3t minus 4, and the shift here is at point 2, so this will be 0 less or equals to t less than 2, and here 2 is less or equal to t, and we just found our piecewise function back by finding the Laplace inverse of this. So for this second example, the first thing we're going to do, we have this term, this function of x, and we can denote this as our g naught of x. This will be our g1 of x, and this will be our g2 of x. So the Laplace inverse of our h of x, which we can denote as h of t, so simply be the Laplace inverse of g naught of x minus the Laplace inverse of exponential negative s1 of x plus the Laplace inverse of exponential negative 4x. Please get this is x, okay? 4x g2 of x. G naught of x, which is 1 over s squared, this simply implies that our g naught of t, which is the inverse of this is simply t. G1 of x, which is 2 over s squared plus 1 over x. This implies that our g1 of t, this will give us 2t plus 1. And then last but not the least, our g2 of x, which is 4 over s cubed minus 1 over x, which implies that our g2 of t, by finding the inverse of g2 of x, will give us 2t squared minus 1. For this particular term, the tau here is 1, and for this term, the tau here is 4, which is the power. This numbers here, and there's a 1 here too. So with that, I can easily say that the g1 tau t minus tau, this will simply give me 2 into t minus 1 plus 1, which is 2t minus 2 plus 1, which would be minus 1. And this is your g1 t minus tau. And for this one, your gt minus tau, here tau is 4, so this will simply be 2t minus 4 all squared minus 1, which is 2t squared minus 8t plus 16 minus 1. And if you open this up, this should multiply the 2 across. You have 2t squared minus 16t. So let's rewrite the function, which is h of t will be the Laplace inverse of, and this we've already found there was no change at this point, so this is just our t. Then minus, here there is a change at point 1, which is ut minus 1, and then here should be our g1 t minus tau, and that we already found to be this, into 2t minus 1. We do the same here, ut minus 4. I'm just applying the theorem here, 2t squared minus 16t plus 31. And this is the inverse of the function. But then, if you want to put it in the piecewise form, recall that here you have your h naught of t. What we have here is h1 of t minus h naught of t. What we have here is h2 of t minus h1 of t. Okay, and having that in mind, I'm just going to put this down here, h of t. For piecewise, this will have something like this. This will be our h naught, this will be our h1, and this will be our h2 of t. Okay, so our h naught is already established, it's just t. So I'm going to put it here, t. For h1, we can find h1 by combining this, and that will be h1 of t minus h naught of t plus h naught of t, and this we know as, this term is 2t minus 1 then plus t, so this will give us 3t minus 1 as our h1 of t, and we'll put that down here, 3t minus 1. Then it's left for us to find our h2 of t. How do we go about it? So here you have this, but now we know what our h1 of t is, so we can easily do our h2 of t will be h2 of t minus h1 of t plus h1 of t. So this term here is equal to this term here, so this will give us 2t squared minus 16t plus 31 plus our h1 of t, which is 3t minus 1, 3t minus 1, and this will give us 2t squared minus 13t plus 30, and that we put down here. 2t squared minus 13t plus 30. And the shift here is at point 1, so this will be 0 less or equals to t less than 1. And here is at point 4, this will be 1 less than or equals to t less than 4. And for here, this will just be 4 less or equals to t. And this gives us back our piecewise function. Thank you, friends, for watching. If you have any questions, drop it in the comments and I'll gladly answer that. I'm going to do one more problem that involves trigonometric functions before I jump right into piecewise continuous forcing functions. All right, and do subscribe. Thank you.